Dear physics aspirants, right now I have the radioactivity 13.6 subtopic of physics, and nuclei chapter will discuss about the radioactivity. A.H. Becquerel discovered the radioactivity in 1896. So who discovered? A.H. Becquerel, and purely by accident, not the intentionally, while studying the fluorescence and phosphorescence of compound irradiated with visible light. Becquerel observed an interesting phenomenon. After illuminating some piece of uranium potassium sulfate with visible light, he wrapped them in black paper and separated the package from a photographic plate by a piece of silver. When after several hours of exposure, the photographic plate was developed, it solid blackening due to something that must have been emitted by compound, and was able to penetrate both black paper and the silver. Experiments performed subsequently showed that radioactivity was a nuclear phenomenon in which an unstable nucleus undergoes a decay. This is referred to as the radioactivity decay. Three types of radioactive decay occur in nature: alpha decay, in which the helium nucleus 2H4 is emitted, it is known as the alpha decay; beta decay, which electrons or positrons, particle with the same mass as electrons but with the charge exactly opposite to that of electron, are emitted; and gamma decay, which is in which high energy, hundreds of kilo electron volt or more photons are emitted. Each of these decay will considered in subsequent subsections. Here the 13.6 and 0.1 law of radioactivity decay will provide you the information. In radioactive sample which undergoes alpha, beta, gamma decay, it is found that the number of nuclei undergoing the decay per unit time is proportional to the total number of nuclei in the sample. If n is the number of nuclei in sample and n undergoes in time t, then n by t is equal to n approximate constant, or n by t is equal to lambda n, where lambda is called the radioactive decay constant or disintegration constant. The change in the number of nuclei in the sample is dn is equal to n minus n and time t. This is rate of change of n in limit t tends to 0, and dn by dt is equal to minus lambda n, and n is the number of nuclei that decay, and hence the always positive dn is change in n, which may I have either sign here is the negative because out of original n nuclei and n have decayed, leaving n minus n nuclei. Here you will see the leftovers, you will see here, and with the help of this picture you can find out here the full picture, and here you will see the future 13.3 exponential decay of a radioactive species after a lapse of t 1/2. Population of the even species drops by a factor of 2. Here the leftovers is also the Becquerel simply equal to disintegration of the decay per second, and here is the photo of Mary Sklodowska Curie, born in Poland, and she is recognized both as physicist and chemist. Discovery the radioactivity by Henry Becquerel. Discovery of radioactivity by Henry Becquerel in 1896 inspired Mary and her husband Pierre Curie in their researches and analysis, which led to the isolation of the radium and polonium elements. He was the first person to be awarded 2 Nobel Prizes for physics in 1903 and for chemistry in 1911. So here is the content, and content is here, and solution some numericals is here, and we will meet in next session with the alpha decay. Till then, thank you very much.